Back in the day, back in November 2021, when I started this project, it's a ridiculous project, I was very careful to count all the turns that came out of each slot. So this drawing right here this is an old drawing. It shows that there were 48 turns in each slot for these 4 slots here. If you remember, we never discussed these 4 slots here when we talk about power windings. That's because these 4 slots contain the exciter windings. I'll get rid of that crap. So the bottom line is that through a lot of mathematical manipulation between engine speed and 60 hertz, which causes a 50 hertz, 60 hertz, and the ratios, I determined the ratios were 19 turns on the 60 hertz half of that split coil and 29 turns on the 50 hertz side of that split coil. So that's why I got this number 19 turns, which we're going to use in a few moments. So this is where this 19 turns came from for winding D. D is this one right here, and it's no longer split. It's no longer separated here. It's tied together right here. And it's 19 turns total. Because we already have 48 turns in each slot, that's pretty crowded with wires. So I'm going to try to incorporate these 19 turns into these 3. Instead, we're going to keep the slot D, I should say winding D, and provide 19 turns there and 48 turns to the other. So you divide these by 2, it ends up being, we'll make it 10 and saturate it even harder. So 10, 24, 24, 24 will be the final windings for the exciter windings. Next, we need to take a look at this annotated factory diagram, which I'd updated today. And this whole section right here, these 2 paragraphs explain how this actually works. So this was in error before. It explains how it takes both halves of the stator to make up one of these phases. So you can read those details if you want to. I also came down here and fixed this, the slot pitches. We have 5, 7, 9, and 11 slot pitches, variable slot pitches on the power windings instead of just 9. 9 was a theoretical, but we actually use 5, 7, 9, and 11. So that helps reduce harmonics. And the other thing we want to do with this drawing is look at the factory spec on the resistance values of the phases. They obviously used a milliohm meter to measure this resistance. So they measure 0.11 ohms for one phase of the battery charger. They measure 0.514 ohms for one phase of the power windings. So the ratio here, 0.11 to 2 of these guys, because there's 2 phases, that's 1.024. So we take the ratio, we take our 0.11, divided by twice that, be 1.024, plus 0.11 be 1.134, 1.134. The ratio is 0.097. We'll call that 10%, 0.1. So it's 10% of these coils are removed. 10% of the loops in each slot are removed because we're removing the battery charge windings, which is only 10%. So that's not as much as I thought it was. It's still going to be a pretty tight wind to rewind the stator. So when we subtract the battery charge windings from the physical count at each slot, we end up with these new counts. There's 16 loops at slot 10 to 15, which is 10 to 15. And there's 0 loops at slot 3 to 22, 3 to 22. Same way with the red windings. The red windings, we have 0 slots from 10 to 15, 0 loops, and 36 loops from 3 to 22. So that's been corrected. Now we can use this table to find out how many loops we need in all 7 slots to match these same numbers. So to do that, we simply, it's not so simple, add up all these loops. We got 39. Let's clear all this stuff. We got 39 plus 43 plus 44 plus 44 plus 43 plus 39 plus 36 equals 288. Divide that by 7 slots, because we could put all those counts into 7 slots. So divide that by 7. Equals 41 counts per slot, and that's for both windings. So divide that by 2. It comes out 20.57. So we'll say 21 turns in each one of these 7 slots will give us just slightly more than the factory has. We never want the voltage to be lower because that causes more current draw. So it'll be 21 turns for every one of these 7 slots. And so now I'm going to return to this particular drawing, this generator wiring diagram coil map drawing. I have repaired all these turns counts. 0 there, 21, 21, 21, etc. I forgot to change this one, 0 here. Text, 0. So now this drawing is correct, and that concludes this video of determining this particular lesson, or whatever you want to call this thing. This video explaining how to revise the coil counts so they are in fact accurate. And notice there was a lot of calculation involved to achieve this, but I'm pretty certain that it's reliable at this time. So that's the end of this lesson, or coil, or video, whatever you want to call it.